Welcome back. Today we're going to go ahead. We're going to take a look at Boyle's law. Previously, we've taken a look at Pascal's law, which deals with a liquid. Now we're going to move into the section of gases. Now, Boyle's law is basically just taking a look at how do the volumes and the pressures of a gas, how are those two things related? Okay. Now let's take a look at this visually first, then we're going to get into some more of the notes. Say I have a nice little volume of gas. We're going to put one, two, three, four little guys in there. They're zipping around, they're bouncing around there because of kinetic molecular theory. Everything is in motion. Okay. Now they're hitting the walls a certain amount, which gives it a certain pressure. Now let's pretend that we're going to take those same four gas molecules. Now we're going to put them in a smaller container. Now when they're bouncing around in there, they're going to have less distance to go to hit the walls. That means they're going to hit the walls more often. And if they're hitting the walls more often, that's going to increase the pressure. Okay, so that's basically taking a look at how the volume and the pressure of a gas is related. It ends up being an inverse relationship. Okay, mathematically, he said V sub 1 times P sub 1 equals V sub 2 times P sub 2. The initial volume, 1 stands for a volume, multiplied by initial pressure will equal the new volume that we get times the new pressure. It's an inverse relationship. If the volume goes up, the pressure is going to go down. If the volume goes down, the pressure goes up. So, with words, Boyle's law, if we increase the volume of a gas, the pressure will decrease, and if we decrease the volume, the pressure will increase. Okay. Now, one other thing I have to alert you to is how do we measure pressures? We're not that used to measuring pressures, so I want to introduce you to a few of these terms. 1 atmosphere. Now, 1 atmosphere is just how much air pressure you are experiencing at sea level. This would be like in San Diego or something like that. If you went up in the mountains, if you're in Denver, you're going to have less than 1 atmosphere. There's going to be less air pressure at higher altitudes. We're going to start out with 1 atmosphere, which is the same thing as 760 millimeters of mercury, mmHg, millimeters of mercury. Now, what that's saying is 1 atmosphere of pressure will push mercury 760 millimeters up a glass tube. And that's the same thing with a third way of measuring pressure, 1 to 1.325 kPa. That's kilopascals. It's just another way of measuring pressure. Now, I would like to be able to apply these in a few different problem-solving settings. We're going to do that in the next video, but first I want to show you, this is how I always suggest kids, this is a framework, how you can solve for the formulas, how you can solve some of these story problems. Now, the first thing I always require kids to do is to write the formula in variable form. That means I want them to physically write down V sub 1 times P sub 1 equals V sub 2 times P sub 2. I want them to use the variables. I want you to use the variables because that will help you organize your thoughts, get them down on paper, and it will help with step 2. Step 2 is figure out what you have in the problem, what's your known values, and take a look at what you're going for. In other words, what ones of these did I give you and what one am I asking for you to solve for? Okay. Now, step 3, that's where the algebra comes in. Now, figure out how you're going to get there. Make a plan for how you're going to find that one piece of information that the question is asking for based on what you already have. Okay, in the next video, we'll go through a little sample of that using that process, and I hope you have a great time.